The China-linked JD botnet, an APT network previously tied to Volt Typhoon, is rapidly expanding its reconnaissance operations directly against United States military networks. This animated diagram illustrates data captured by researchers at Black Lotus Labs. It shows the network scaling from roughly 650 active bots in January 2024 to over 1,500 compromised devices today. While 1,500 nodes might seem small for a botnet, this scaling represents a highly focused strategic intelligence gathering campaign actively mapping critical U.S. infrastructure. JDY operates differently than typical malware networks. It is designed specifically as a distributed scanning and fingerprinting tool, avoiding the brute force swarm tactics of a standard DDoS attack. Its primary strategy relies on speed. The network identifies and maps targets that are vulnerable to specific flaws immediately after those vulnerabilities are disclosed to the public. This timeline graphic demonstrates how the operators operationalize that intelligence. Shortly after Fortinet publicly disclosed a flaw in FortiClient EMS, JDY immediately initiated scans targeting that specific vulnerability, identified as CVE 2026-35616. This methodology effectively erases the patching window for network defenders. Public vulnerability disclosures are immediately weaponized into actionable targeting data for threat actors. To build this reconnaissance grid, operators are actively compromising everyday small office and home office routers, alongside connected IoT devices. This graphic breaks down affected hardware. Compromised devices include models from Cisco, Arachnus, Mimosa, Ubiquiti, Draycheck, Hikvision, and Linksys, targeting MIPS and MIPS derivative system architectures. Threat actors are intentionally exploiting these unmonitored, consumer-grade networking products to construct an invisible platform, launching scans against advanced military targets from domestic IP addresses. Operators control the botnet through hidden Tor services, routing instructions to a dispatch service. Once compromised, Soho malware registers with that dispatch service, awaiting scanning assignments. With root privileges, it bypasses protocols to initiate high-speed raw SYN scanning using custom TCP packets with a fixed source port of 19,000, batch processing targets, then compressing and returning results. This distributed, multi-tiered architecture allows the operators to conduct high-volume, automated reconnaissance at scale, all while thoroughly masking their true geographic origins. Organizations must immediately secure their external attack surfaces to prevent their edge devices from being recruited into the JDY network. This checklist outlines the required remediation steps: apply all current security updates, disable internet-exposed administrative interfaces, restrict remote access, replace default credentials, and monitor outbound traffic for scanning activity on fixed source port 19,000. Neutralizing the JDY threat requires administrators to stop viewing consumer edge devices as simple internet appliances and start treating them as critical security perimeters. For more objective, data-driven cybersecurity briefings, please subscribe to our channel.